Welcome to Garland's Application Excellence Series. Our topic this time is self-adhered roofing systems. Whether it is to limit impact on building owners, to roof areas with difficult access, or to eliminate odors, self-adhering modified bitumen systems continue to gain in popularity in the low-slope commercial roofing market. However, this unique roofing system requires special attention to ensure a long-term, watertight solution. Before getting started, it is important to note that weather is one of the most critical requirements for self-stick systems. 40 degrees Fahrenheit or 4 degrees Celsius and rising is typical for most roof systems, but self-adhering roofs require 50 degrees Fahrenheit or 10 degrees Celsius or above and rising through the day. The bond of self-adhered membranes will not be at full strength immediately, but will often require some time and heat to gain full bond strength. In addition to the ambient temperature, the substrate and temperature of the materials are also critical. Materials that are stored on the roof are often exposed to very cool nighttime temperatures. These materials must be allowed to warm and relax before being properly installed. Just as cool weather can have a negative effect on bond strength, extremely high temperatures can also have a detrimental effect on self-adhering systems. The ideal temperature range for self-adhering systems is between 50 degrees Fahrenheit or 10 degrees Celsius and 100 degrees Fahrenheit or 38 degrees Celsius. It should also be noted that the nature of the self-stick compound is much softer than conventional modified bitumen systems. Therefore, in extreme heat, these sheets will be softer and may require special protection, especially in walkway areas. Self-adhering products should be stored in their original boxes, indoors on pallets, and protected from the elements. Rolls that are improperly stored or have been warehoused for prolonged periods of time will potentially have a negative impact on the self-adhering properties. As with all roofing systems, do not attempt the application of a self-adhering roofing system if ice, snow, moisture, or dew is present. For self-adhering systems, it is critical that the substrate is clean, dry, and free of dust and other inhibitors that will prevent proper adhesion. Additionally, phased roofing is not permitted with self-adhering roofs. Blisters and improper adhesion is likely to occur on phased projects. Most self-adhering roofs will have one or more layers of roof insulation. Polyisocyanurate, wood fiberboard, and perlite are not acceptable for direct adhesion of a self-adhering system. However, coverboards are recommended for direct adhesion of self-adhering systems. Approved coverboards are Densdeck Prime, Densdeck Duragard, or Secure Rock. These coverboards, even Densdeck Prime, often have a powder or residue on the surface of the board. Lightly priming the surface with an asphaltic or acrylic primer is highly recommended and will significantly improve adhesion of the base sheet to the coverboard. When cutting insulation board and working around projections, be sure to completely clean the substrate of insulation dust, as this is often the source of bond-breaking agents on self-adhering systems. When installing Garland's self-adhering system over any substrate, start the HPR SAFR base sheet at the low point of the roof with appropriate roll width to offset side laps 18 inches from side laps of the base sheet. Extend the HPR SAFR base sheet over the fascia a minimum of 2 inches and nail 9 inches on center. Design the layout so that no side laps are against the flow of water. Then, fold the membrane in half lengthwise to remove the split release film. Press the membrane securely into place and repeat with the other half of the base sheet. Immediately roll in the membrane using a heavy, weighted roller over the entire surface of the base sheet to secure the membrane to the substrate. Work outwards to eliminate trapped air. Some contractors prefer to position the base sheet and remove the split release film from underneath the membrane. This technique requires 2 workers to prevent shifting. Often, workers will cut the rolls into more manageable lengths for easier application. Overlap side laps of subsequent HPR-SAFR base sheet 4 inches and end laps 8 inches. Be sure to stagger the end laps a minimum of 3 feet. Before adhering HPR-SAFR base sheet or stress ply SAFR mineral end laps, trim the underlying sheet's lower outside corner at the end of the roll. Follow with the overlapping sheet, trimming the upper outside corner. Corner shall be trimmed on a diagonal angle of 5.5 inches long from the end of the roll to the outside edge. The width of the trim shall be equal to the 4-inch specified side lap. Trim corners shall be completely covered by an application of succeeding courses. Proper T-joints are critical with self-adhering projects to prevent any capillary action. Note, when installing HPR-SAFR base sheet, apply a quarter-size dab of flashing bond or Garlaflex at the T-joint area. Another key requirement of all self-stick systems is end laps and flashing details. Since there is no additional adhesive between the base sheet and cap sheet whenever there is an overlap at minerals, in other words, end laps and flashing details, it is critical to butter the minerals with a thin, uniform layer of flashing bond or Garlaflex. This will allow proper bond of the system. Use of a handheld hot air gun is recommended at the joint area prior to rolling the membrane to maximize adhesion. Immediately roll in the membrane using a heavy weighted roller over the entire surface of the HPR-SAFR base sheet to secure it in place and prevent voids, working outward from the center of the sheet. Repeat the above steps to properly build 1 to 2 plies of the HPR-SAFR base sheet as specified. Don't leave the installed HPR-SAFR base sheet exposed to weather. Cover with stress ply SAFR mineral cap sheet the same day. At all vertical and other flashing details, install HPR SAFR base sheet and stress ply SAFR mineral over the already installed stress ply SAFR mineral field plies. Prime the horizontal surface with Garland-approved primer and allow to dry. Over the existing installed stress ply SAFR mineral field plies, apply a 3-foot wide HPR SAFR base sheet extending a minimum of 10 inches onto the field of the roof. Apply a uniform 1/8 to 1/4 inch thick troweling of flashing bond or Garlaflex onto the existing stress ply SAFR mineral field cap. Before installing stress ply SAFR mineral flashing to mineral surface field ply, apply flashing bond or Garlaflex wherever the membrane overlaps onto mineral surfacing. Proceed with stress ply SAFR mineral cap sheet installation. Apply a 3-foot wide stress ply SAFR mineral extending a minimum of 10 inches onto the field of the roof, being sure to cover the base ply. Once the membrane has had a chance to bond, check all laps and joints for full adhesion. If the membrane can be lifted at any area, it is not properly adhered. A seam probing tool can be helpful to check for small voids at laps. If necessary, use an appropriate handheld hot air welding tool and seam roller to seal small unbonded areas if they exist. A few final important recommendations for self-stick applications include: extremes in temperature can affect the application of self-stick systems. Self-adhering membranes must have a smooth substrate to achieve a proper bond. At end laps, flashings, or wherever the self-adhering membrane touches a mineral surface, apply a uniform 1/8 to 1/4 inch troweling of flashing bond or Garlaflex the full width of the end laps to ensure proper adhesion. T-joints are critical for self-adhering roof systems. Flashing height should not exceed 24 inches. Attach an insulation board if the flashing substrate is block or plywood. Often, it is recommended to install flashings in a cold process adhesive in self-adhering systems. Use a heavy weighted roller, working outward from the center of the sheet to prevent voids. A handheld hot air welding gun can be used to warm the lap areas and improve adhesion, especially when temperatures during installation are cooler. Quality inspections during installation are especially critical in all systems that are more installation sensitive. Probe laps to look for open seams. Do not peel the sheet, as it does take time to achieve full bond strength. Always refer to the specification for complete requirements. Customers today are demanding more environmentally sensitive applications. Self-adhering roof systems are here to stay. When installed properly, these systems provide building owners with long-term, leak-free buildings.